All right, let's do this. So, welcome to getting started with OpenTelemetry. So let me get rid of these questions here. And then let's go. So OpenTelemetry, super high level overview. Why did we even call the project OpenTelemetry? So the reason we did that is telemetry is an existing word. And what telemetry means is it means generating and transmitting instrumentation signals about a remote object or process and sending it somewhere where it can be analyzed. And that really describes the boundaries of the OpenTelemetry project. It's really about the generation and the transmission of these telemetry signals. We believe this is the part of observability that can be standardized, and that would everyone in the field would really benefit from working together to standardize how programs describe themselves and how programs are observable in a way that's somewhat language neutral. So I want to be able to look at my distributed system, which is a polyglot system made of all different kinds of components, and see some kind of coherent story for what it's doing. And that's really the bread and butter of OpenTelemetry. So let's go straight into just the big pieces of how the project is laid out. So if you have a process represented by this green circle here, and you're going to install OpenTelemetry in it, the first thing you're going to install is the SDK. So the OpenTelemetry SDK is the implementation part of OpenTelemetry. So this is the framework part. When you start your program up, the SDK is the part that you configure. This is where you would install plugins and lifecycle hooks. And you only want to do this during program setup though, because the thing about all of these details is they're all kind of under the hood details. We don't want, because we want OpenTelemetry to be flexible and work in a lot of different ways, there's a number of details we don't want to necessarily expose to instrumentation or to the application. For example, what kind of headers are you using? What kind of exporter format? Because all of these things are flexible, we don't want people to depend on OpenTelemetry working in one particular way. So the SDK is where you set up all of that flexibility and do all of that framework work. But once you're done setting that up during program initialization, generally speaking, you should not be touching the SDK anymore after that point. In your actual application code where you're doing instrumentation, you want to touch the API. So the API layer is the kind of the opposite of the SDK. It contains no implementation. It's almost entirely made up of interfaces. It also has some constants and other tools to help with data standards. But it doesn't necessarily contain an implementation. In fact, it can support multiple implementations. Besides just using the SDK as a framework for plugging in different components, you could actually toss out the entire SDK and plug in an entirely different SDK under this API. So it's truly taking the concept of loose coupling between large components to have a clean observability API like this. And it's actually really important for something like observability, because observability is a cross-cutting concern. All of this observability code gets mixed in with all of your other code. And so that's really a hallmark for where loose coupling can be helpful, because you don't necessarily want to be tying all of this stuff together to the specifics. And by the way, an example of multiple implementations and why you might want this, a classic example I like to use is a C++ implementation, or these days maybe even a Rust implementation. But rather than using a language implementation, in some languages, especially dynamic scripting languages, it may be a lot more efficient to have an SDK that was entirely just foreign function calls to the C++ OpenTelemetry implementation. So by having the API and SDK separated like this, that allows a lot of this flexibility going forwards into the future to come up with better, more efficient ways of doing this stuff. Okay, so the next major component is actually not a component of OpenTelemetry, but it's all of the code in your system. We'll get into this, but there's an aspect of distributed tracing which requires everything to be instrumented because you're trying to have some kind of context, everything being contextualized properly. So with logs or with just metrics, you can just make a standalone log line, or you can make a standalone metric. There's really no such thing as standalone tracing. So when you go to set up your program, you really need to look at all of the libraries and frameworks you're using to manage network connections and control flow within your application. So the most common one here is going to be your framework, right? That's either a web framework that all of your application code is going into, in which case that web framework contains just a huge amount of information and it's doing a lot of work on your behalf. So getting that thing instrumented will give you a large amount of coverage. But you also want to look at frameworks that are literally controlling control flow. So for example, something like Akka actors or any sort of coroutine implementation, anything that's swapping threads or moving work around or changing the context of what work is active, that framework component needs to be integrated with OpenTelemetry in order for it to work. Likewise, for the network connections, if you have an HTTP client or a database client or anything like that, those are critical libraries to have instrumented. Again, not just to get the information out of your system, but to also propagate this context. So that's really critical. OpenTelemetry comes with a number of plugins for popular frameworks and libraries. Luckily, for the most part, we share a lot of this code. People don't tend to go write their own HTTP client just to make a website. People don't always make their own framework, though they sometimes do. So this is where the sort of auto instrumentation aspect comes in. We want to have instrumentation for all of these common components ready for people to use out of the box. Okay, so that's everything that's happening inside of your process. You've got your SDK, you've got your API, and that's talking to a bunch of instrumentation code, some of it in your application, but most of it in your libraries and frameworks. What happens next? What happens next is that data gets exported off of your system. So the SDK has a plugin model. It comes with a number of standard exporters. So OTLP is the OpenTelemetry's default protocol. This is the protocol we invented for OpenTelemetry. It contains all of the data. Most of the existing protocols tend to be separated into verticals, right? So they contain tracing data or metrics data, but they don't necessarily contain both. And OTLP contains all of the data. So that's the primary protocol to use for exporting the data out of your system. But you can install an SDK level exporter if you don't want to use OTLP. You can use Zipkin, Prometheus, Jaeger. There's a number of standard formats that are built in. And as Ariel asked earlier, is it possible to create custom exporters? And the answer is yes. This is all a framework system. So you can totally write your own exporters if you have your own data format that you want to use. All of that data then gets sent to a separate process called the collector. So the collector is the other major implementation component inside of OpenTelemetry. Besides the language SDKs, you've got this collector, which can run as a sidecar or as a gateway. And what that does is it's sort of like a data processor. That's the place where you're going to be translating between data formats. You're going to be massaging your data in various ways. It's a really useful component. And so that's sort of the transmission part of the telemetry system. The API and SDK are the generation part, and the collector is the transmission part. One thing you will not find in OpenTelemetry, though, is analysis. So the idea here is OpenTelemetry connects to a bunch of different analysis systems, but we don't really want to replace those. So OpenTelemetry doesn't come with its own analysis system. And by analysis system or analysis tool, I mean something like Lightstep or Datadog or Jaeger or the Zipkin backend. anything that's going to store all of this data and do something useful with it is an analysis tool. And the reason why that doesn't come in with OpenTelemetry is because OpenTelemetry is a standards project. We want to standardize how we're sending this data, but there's not really such a thing as standardizing how we analyze this data. Analyzing this data is actually where a lot of innovation is going on currently. So the hope with OpenTelemetry is that by getting everyone to standardize on what the data is and how we're transmitting it, that will actually really create a boost in the realm of creating new analysis tools. Because if you want to create an interesting form of analysis for this data, you can just go do that now. You don't have to write all of these other components. And back in the day, if you're writing a distributed tracing system, you would have to do that. You would have to write, you know, the collector, the SDK, you would have to write all of the instrumentation, which is not complicated code, but it's a huge amount of code. And so by standardizing all of that, we're really hoping to see analysis take off and to see sort of a golden era of observability come on. So that's really the high level goal for the project. Now, how we actually make all this work in all of these different languages and have some kind of unification is something we call the spec. So I'll walk through the actual GitHub organization so you can see this. But basically, we have a language neutral spec where we define all of these things. And then from that spec, we then create implementations in all of these different languages. And I see there's a question here, does a collector equal the Lightstep satellite? Okay, that's a good question. So no, they are not equivalent. For people who don't know Lightstep, we had something that sort of looked like a collector called a satellite. The difference between these two things is that the satellite actually is an analysis tool. So if you're running Lightstep with OpenTelemetry, you're still going to want to run something like a satellite or, you know, a hosted version, some version that we run for you. At one way or another, there's something like a satellite involved when you're talking to Lightstep, because the satellite is actually part of Lightstep's database architecture. That's sort of the live in-memory fast layer of our database where you can access all of the live traces. Basically, you have access to your complete live system. And the collector is not any of those things. The collector is purely data transmission. So the collector you're using to send the data from point A to point B, to buffer it and deal with, you know, network flakiness, trouble, components coming and going. And it's also where you would do like data massaging, scrubbing sensitive data out of your system, et cetera, et cetera. And you don't really do any of those things with the satellite. The satellite is really like a database component. So hopefully that answers your question. Okay, let's switch gears and do a GitHub walkthrough now, just to give you a sense of this project. But first, any questions at this point about what we just went over? Here, I'll go back to the last slide so you can see it. And GitHub has a capital H. My bad. I put a capital M, a capital S in Microsoft the other day and got a look. So I'm always screwing that up. Okay. So doesn't seem like too many questions right now, but feel free to just throw them out there as we go. So let's just look at this project on GitHub. So if you go to OpenTelemetry.io, you know, you'll find our website, but all of the good stuff is actually here in GitHub for the time being. So let's just have a look. So if I pop up to the highest level of the OpenTelemetry organization, there's a couple pinned repositories that are super useful if you're just trying to get an understanding of the project. A super important place to start is community. So the community repo, this is just where we keep track of how we do things. So if you want to understand who does what in the project and how the project is actually set up, we have a governance committee, we have a technical committee, we have various roles in the different projects like maintainers and approvers and things like that. And you can read about how all of that stuff works here. We do a lot of meetings. We talk a lot on GitHub, but we also like to have every working group meet once a week. So you can find the OpenTelemetry calendar. I highly recommend that calendar. It's really great to show up to these meetings if you're interested. And we also have a set of mailing lists that we basically don't use. We're really not very email focused, but they are here if you want them. And mostly we hang out on Gitter if we want to chat. So there's a couple of Gitter rooms that you can find here. So the easiest way to actually just get involved in the conversation and ask any kind of question is to hop onto Gitter, find the room for the project you're interested in, and ask the question there. We're on Gitter all day, so that's really the best place to go. Okay, so that's how you learn how to get involved with a community. How does the actual spec work? That's in the specification. This can be useful to do a read through of at some point. I mean, this, if you're trying to put yourself to sleep, it's good for that. But it does really go over a lot of the details. So if you're trying to understand what some of these terms mean, or like what the point of some of this is, the API docs at this time don't tend to go into that a lot, but you can go here and look at the API specification for tracing. And this will tell you a lot of detail about what the point of this stuff is. So not just the overall structure, but also like what are the reasoning behind some of these parameters you have to pass and what do they mean? A lot of this stuff is not necessarily super documented in the API docs because the project's still in beta, but you can find a lot of the information in the specification. So this is actually a useful resource, even if you're not doing an implementation, if you just want to wrap your head around how OpenTelemetry works. I do recommend looking through the specification. In particular, these semantic conventions. This is where we're trying to define conventions for how to describe common operations like HTTP calls and database calls and stuff. It's good to get an understanding of how these data semantics work in particular. Like if you want to describe an HTTP request, this is about, you call the method http.method and it's a string and it's in all caps and it looks like this. We're really trying to standardize this stuff as much as we can so that analysis tools can be presumptive and can have some semantic understanding about what these traces are. It's one thing for a system to just see like a trace or a span or an event. It's another thing for an analysis tool to see an HTTP call. And so these semantic conventions are how we're trying to get those high-level concepts into the data so that there's actual meaning behind this data that these analysis tools can make use of. So that's a good reason to go look at the spec. If you're interested in how changes get made to the spec, we have an RFC process. So OTEPs here is what we call them, the OpenTelemetry Enhancement Protocol. You probably won't be making one of these if you're not working on it, but just to let you know, this is how change gets made in the project because we care a lot about backwards compatibility. There's so many implementations. We do want to have something like an RFC process that gives a chance for everyone to weigh in and work it out before we go baking all this information into the spec. So there's a proposal process you can look through. You can see we've already had a substantial number of OTEPs so far. And so that's how the project actually works. The community repo, the spec repo, and OTEPs are like the core of making change and defining the project. And then the proto repo, that's where we're defining OTLP data protocol. Okay, that's the project overview. Any questions about that part? Doesn't look like it. It's pretty straightforward. Okay, so let's move on a bit to just cover some of these core concepts behind distributed tracing and OpenTelemetry in particular. So just a reminder of the kind of transactions we're trying to capture here, because OpenTelemetry is all about distributed transactions. There's a lot of different kinds of workloads and things you can look at in this world, but distributed transactions are kind of the bread and butter of cloud-based computing technology. And so just for clarity, what we mean by distributed transaction is, you have some client, let's say this is a mobile client for a service that lets you upload a photo along with a caption. Okay, great. So this client is going to make a network call to a service. Of course, it's not going to be one service. It's going to be a whole pile of services, right? Like it might hit a proxy first, that's then going to talk to an auth server, and then maybe that proxy writes a photo down to some scratch disks, and then it calls your application, and then your application processes that thing and uploads it all to some kind of cloud storage. Once it's uploaded, it writes down what it did in a database by calling a data service that keeps that information cached in Redis, and then writes the rest of it to SQL. Whew. So I wouldn't even call this microservices. I feel like I've been looking at like LAMP stack apps that are basically this for like 20 years. And this is a thing I always point out is like, even back then, we had this annoying problem of there's a whole bunch of services involved. And if I want to reconstruct one of these transactions, it's kind of tricky to do because there's not a lot of context, right? So just to give a sense of that, here's another way of looking at, so here's like a service map description of this transaction. This is more like a call graph description of this transaction. So when you're looking at traces, you tend to look more at a display like this, where the length of the line represents how much time that operation took. Each line is an operation. Each of these connecting lines is a network call, and the colors just match the services here. So you have your client. This, of course, the client is open for the entire transaction. It talks to the proxy talks to your auth server, the proxy uploads the file, talks to your app server, blah, 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 blah. So that's what's going on there. And things that we can find when we look at this kind of contextualized data, first and foremost is latency, right? We can see not just how long things are taking, but we can see where the time is being spent. We can also see where time is being spent waiting. So you can see this client, it takes a long time, but the client is only doing work for a very short amount of time in this transaction. For the most part, the client is sitting there idle, waiting for the transaction to return. And the work is actually being done somewhere else. And figuring out where that work is actually being done is what we refer to as the critical path. So that's the stuff that's really gonna let you hone in on what to actually optimize, because there's no point in optimizing something that's just waiting or something that's not really gonna affect the overall latency of your transaction. So that's one thing we care about. The other thing we care about is errors. Where did the error happen? Did it happen here? Did it happen in this component? Did it happen in that component? That's really important. And then, of course, events. Events are just logs. For some reason, people make a big deal about trying to say that distributed tracing and logging are different. I don't subscribe to that view. I actually think distributed tracing is just logging. It's just logging with all the context that you actually want in order to analyze the data. That's the only real difference. But of course, you're going to want these events. These are just your log events that tell you all the little steps that actually went on in that transaction. And then last but not least, of course, correlations. This is like the big win of OpenTelemetry. Having all of this context is that you can correlate these events really easily. Not just the events within a single transaction, but across transactions. So this error you're seeing, are you seeing this error? Does this error correlate with a particular project ID? Does it correlate with a particular host or region? Is it a particular endpoint? What are the commonalities with an error? So those kinds of correlations are really important to root causing your issues. And if your data is not contextualized properly, then doing this kind of correlating is just really time consuming and labor intensive. At least that's what I've found. Another way of thinking about this is you have this issue of like the logs that you have versus the logs you want. You have all these logs across all of these different services. And if what you're trying to do is find just the logs that were part of that one transaction, if you don't have some kind of ID that indexes all of those logs by transaction ID, then it can be really hard to piece together a single transaction. That can be kind of tricky to do. And if you start trying to get that transaction ID into every log, that really just takes you down the road to distributed tracing and OpenTelemetry. And that leads us to this core concept, which is context propagation. This is the thing I really want people to understand about the OpenTelemetry model. I don't think you can really debug or reason about distributed tracing or OpenTelemetry unless you understand the basics of context propagation. So we're going to go into this and then switch gears a bit. So what do I mean by context propagation? Okay, so you have two services, right? And these services have a transaction that connects them. So you've got some operations in service A, a network call, and then some operations in service B. Within a service, you have context. So what context means is these operations represent a call graph, and each operation is contextualized. There's some kind of environment or context occurring that's specific for that transaction. It might be specific for that operation. And that is following the path of execution. So you always have this context available when you're executing code. So that's one part of OpenTelemetry, is making sure this context is following your code and always available. If you're a Go programmer, this is super normal, right? Go literally has a context object. It's one of the few languages that has this as sort of an explicit first-class citizen. You know, for better or for worse, you do it all manually, but I do think Go programmers understand context. This is actually harder to explain to programmers in other languages because unless they've been mucking about with thread locals or something, it's just not common. For Go programmers, this is common. So you know what I mean when I say context. It's really the propagation part that is new for Go programmers. Because what you're doing with propagation is you're taking this context or some portion of it and you're serializing it as metadata. So if this is HTTP, the metadata is going to be HTTP headers. So right when you make the network call on the client side, you're going to inject this context into your HTTP headers. And then on the server side, you're going to extract that context from those HTTP headers and resuscitate it as a new context object that keeps on going. So the core concept behind distributed tracing and OpenTelemetry is basically, imagine if you had Go's context object and you made it distributed. So anything you put in there in one service might be available to another service down the line. So that's really the core of what OpenTelemetry does. And all of the observability that OpenTelemetry does is built on top of this principle of storing all of these useful indices and data structures in a context object and letting you manipulate it behind the scenes. So speaking of propagation, I just want to let you know there is some other standardization going on here outside of OpenTelemetry. Inside the W3C, which is the group that standardizes HTTP and HTML and all the web standards. A number of us, mostly people who have been working on the OpenTelemetry project, including me, have been working on trying to get some actual standard headers to do all of this stuff added to the HTTP spec. So one header that's already well along is called trace context. So this has two fields, trace parent and trace state. If you use B3, it's very similar. But this trace parent header, this is what really has the main goods. You have your trace ID, which is basically that transaction ID I was talking about. And you have a span ID, which is an operation level identifier. So those are your core contextualizing identifiers. There's also a thing called trace state that's kind of internal for tracing systems. You don't really need to worry about that thing. In addition to trace parent, there's another set of headers coming along called baggage. And while trace parent is tracing specific, So there's some actual meaning to this IDs. Baggage is totally arbitrary. It's just arbitrary key value pairs. And so this is that generic context propagation I was talking about. And so this collection of headers, by standardizing on them and getting all the software in the world to accept these headers and propagate them and interoperate, that's really going to take a big pain point out of distributed tracing, which is connecting all of this stuff up and not having some official way to do it. Okay, yeah, so getting into SDK setup, we do recommend Go, Python, JavaScript, and Java at this time. I should warn you, everything is still in beta, so there are breaking changes still happening, but I do consider this code to be production ready. You just may have some API changes to contend with in your application code. And as part of doing the setup, and we'll walk through this together, after you get all set up, you want to make sure that you're actually verifying things. This really should have been part of the rolling out stuff later. I'm not going to go into this now. We can go into this later. Let's just walk through the code. I feel like I've been talking forever. Let's get some hands on some keyboards. But before we do that, are there any questions at this time? I see I've got some stuff in the Q&A already. So one question coming in is, in your experience, has it ever happened that baggage is slowing down things in the application? How do you identify that? Yes, something to mention here with baggage is that it's going to add bloat to your HTTP requests, right? Like, obviously, the more HTTP headers you add, the bigger that request is going to be. So that will eventually cause some slowdown if you're adding too much baggage. So there is like that qualifier with baggage is you do have to think about it. It's not free. You are going to steadily make your payloads larger the more baggage you add. But besides that, it doesn't really, I don't think baggage in my experience adds a lot of latency. OpenTelemetry, of course, does add some latency, in general, but not baggage in particular. So the best way to identify where baggage is causing your problems is just to have a look at the size of your HTTP headers. If you're noticing that you're ending up in a situation where you're sending, say, tiny payload messages with just a huge amount of header information to do the tracing, I could see that being a place where baggage actually caused some latency issues. So that's how I would look into it. Okay. Do I recommend doing both tracing and logging separately inside the app? I have seen cases where tracing doesn't give a clear picture. If I want to focus on a sequence of events a particular service is doing. That is interesting. I would love to dig into that more. I personally see tracing and logging as I mentioned before, as the same thing. The only difference is traditionally people have tended to use sampling in their tracing system and not use sampling in their logging system. That's part of why I think people sometimes get the impression tracing isn't great for root cause analysis, because yes, if you're sampling everything, it's not gonna be an effective auditing tool. But I do think that form of preemptive sampling is kind of getting phased out. Lightstep doesn't work like that at all. We take 100% of the data, so there's no sampling going on. So in that case, it's no different than logging. And I think you're going to see a lot of other systems moving to something similar. So personally, I just see tracing as a form of logging with better identifiers. But if you do have a logging system that you want to keep using, what I suggest is making an OpenTelemetry plugin to attach all of those tracing identifiers to your logs. So if you want to keep using your logging system, you can do that, and tracing can improve it by adding, trace ID, span ID. If you start stapling all of those things onto your log statements, then you're going to improve your logging system, because it's now going to effectively be something like a tracing system. It just is piggybacking on another system doing the heavy lifting of propagating all this stuff. So I don't think it's necessary, but as a transition, yes, you can totally use logging and tracing together. Okay, next question. When do you expect to have a GA for Golang and or Ruby? Oh man, good question. We are so terrible at predicting deadlines in OpenTelemetry. Every time we predict a deadline, we're just like ridiculously wrong. The project has actually shaped up and become a lot more organized. So one place, if you're really caring about how fast things are going, you can look at projects. And we do have, there's a Go release candidate project that you can follow. This will be probably the most accurate thing as far as Go getting out the door. And then you can also have a look at the GA spec burn down. So in order to GA any of these implementations, first the spec has to get finalized. And this project follows all of that GA work. So you'll notice we have a lot of tagging going on. So if you look at anything, you'll see things are set as their priority. They also have markers on them as to whether they're required for GA or not. So you can actually get a fair amount of information from these backlogs if you're interested. But ballpark, we're hoping to have this tracing spec frozen very soon, in like a week or two. And I'm hoping to at least have a release candidate for the stable release candidate for the tracing systems by end of year. We were hoping by end of November, but you know, I struggle to really push an OpenTelemetry deadline when we've blown through them all in the past. So hopefully that's helpful. Do all systems have to use OTel W3C context? Is there a way to migrate? Yes. Yes, you can migrate. There's not a requirement that you use the W3C headers. All of that is totally configurable. We'll show you how to configure it. You do have to make sure all of your systems are using the same headers to propagate. Otherwise, propagation is not going to work. But one way you can do migrations is you can actually install multiple propagators. So there's a thing called a stacked propagator. So if you would like to receive, say, W3C, a new header plus an old header, you can use these stacked propagators. So what that says is, I will go in order, and if I see a W3C header, I'll take that. If I don't, I'll look for B3 headers. If I see those, I'll take that. And then I'll look for, you know, OT headers or something like that. And then likewise, when you go to inject and propagate those headers, you can have a choice of propagating one header type or even potentially multiple header types. If you want to propagate both W3C and a legacy header at the same time, you can do that. Obviously, that's going to bloat the payload of your requests, but that is one way to have a zero downtime transition. It's just to propagate both kinds of headers until all systems can accept the W3C headers, and then you can remove the old header type. That's how I'd recommend taking that approach. Okay. Can it be controlled dynamically, say sampling 10% of traffic and increase it as needed? Yes, sampling can be controlled, but I should point out sampling is actually analysis tool dependent. So this is actually a footgun in OpenTelemetry. It's one of the only ones, which is you can install sampling plugins and things like that. But if the tools you're using to analyze that data aren't aware of the sampling that you're doing and are not compatible with that kind of sampling, you're going to screw up your data. Those tools are expecting a certain kind of sampling or no sampling. And so if you do layer something on top of that, just be warned, that may not play well with your analysis tools. So really the way sampling should be approached is to just sort of do whatever your analysis tool wants you to do. And then possibly layer something on top of that as like an alternate system if you want to have two ways of doing it at the same time. That's where having a framework is helpful. You can install multiple span processors, multiple exporters, things like that. More questions. Can we share attributes between parent and child spans when using a logging exporter? I'm not entirely sure what this means. Sharing attributes between parent and child spans when using a logging exporter. You can, I guess I'm not totally sure, Ariel, what you mean by sharing attributes between parent and child spans. So maybe if you could clarify that question, I'd be happy to answer it. And then your parent has a username tag. Yeah, I think I know where you're going with this, Ariel. Yeah. Yes. So this is a trick. We'll get into this at the end of the talk, but yes, this is definitely an issue. This again is somewhat analysis tool dependent. So the way the data shows up is, the attributes are only going to be on one span. So if you put an attribute like username on one span, the attribute is not automatically going to be put onto the child span or anything like that. However, some analysis tools may take all the attributes and do trace level indexing. So you can say, hey, find me any trace that has this attribute. But that's actually a pain point right now. A lot of systems, I think including Lightstep, don't have a great facility for looking for attributes across spans. So find me the trace where span A has attribute B and span C has attribute D. That, depending on your analysis tool, that can be tricky to do. So I'll get into some details later, but I believe the solution to that is you should actually have coarse-grained spans. There's not a lot of advantage of having lots and lots of tiny spans unless you're really trying to measure some specific latency problem. You should favor coarse-grained spans and get all of your attributes kind of pulled together. That creates a better indexing scenario, in my opinion. Okay, one more question. Stacked propagators are only available in OTel SDK, right? Not in Lightstep SDK? Oh, no, we've got, in some of the old Lightstep stuff, we do have stacked propagators. I think it depends on which Lightstep client you're talking about, because those are a little lumpy, they're not all the same. But that is a concept. We actually came up with that concept and added it to OpenTelemetry. So they're definitely around. My memory of our Go implementation is a little fuzzy though. I believe we've got stack propagators in Go, but I don't totally remember. Okay, that was a good question session. Just having a look at our agenda here. So we look like we're doing well on time, which is surprising for me. I'm either totally digressing and going really slow or speaking a mile a minute and we're like twice as far as we should be. So we could have room for, oh no, Ariel, you're not derailing the presentation. I really want to answer all these questions. I actually think these workshops are more helpful with questions. I think if one person has a question, probably a number of people have that question. So it's worth answering them. I'm a little bit sad that we can't actually do live talking on this. So that's really how I would prefer to do it. But we definitely have time for a couple more questions at this point, or we can move on to the code walkthrough. Cool. Well, let's do a code walkthrough, and then we'll take a break after that, and then we'll come back for more high-level discussions about, how should I roll this out? How should I adopt this? That kind of stuff. Okay. So code walkthroughs, live code, always a fun time. So I'm going to go here. I'm going to make new dir. I'm going to call it walkthrough. And then I'm going to just say, go mod init. And let's start Open up my code editor here. So we're just gonna make a simple client server example. So first I'm gonna make a server. Main. Okay, your basic Go server. Let's see if I can get code a little bit larger. If you're having trouble reading my code, please speak up and let me know. And by the way, you can also follow along on this if you go to Tetsuo Hotel Go Basics. I've got this all typed out, so you can just play around with that Go code as well. So hopefully you've got a Lightstep count made at this point, and we can get started. So how does this work? So let's just make a quick example server for starters, right? So if we were to make a server, you know, you're just going to say, we're going to have some func. Let's make hello world. So a hello handler, right? Typical stuff, right? And so what do we want to do here? Let's just have the world's dumbest thing, and we're just going to write out, you know, hello world. And then let's just add this here. So dp dot handler just say listen and serve locally. And I did something silly, which is I need to add a route. There we go. Still mad at me. Undefined new handler. Is that really true? Yeah. And then maybe I have these backwards. There we go. A little bit. All righty. So that's your basic server. Let's just try running it. So go run. Gmod should install some stuff. And it's probably running. So if you go to local 9000, hello, there we are. Okay, world's most basic thing. All right, so how do we add OpenTelemetry to this? So something me and my team have been putting together at Lightstep are some nice, convenient wrappers for SDK setup. Right now, SDK setup works very well, but it's not packaged up. It's well factored, but when you're just trying to get started with like the basics, it's helpful to have some packaging there. And in fact, I think OpenTelemetry is going to move towards a distro model where you'll have a number of OpenTelemetry distributions that have pre-installed plugins and exporters and things like that. I think something like that will make it a lot easier to have OpenTelemetry connect to different backends. But anyways, let's get this connected up to Lightstep. So to do that, you want to check out the Lightstep launchers. So these launchers are just things that make it really easy to get started. So you've got our launcher, you can go get the launcher, and then it's really easy, right? So just to get started, the launcher is going to tell you to configure OpenTelemetry. There's two required components if you're talking to Lightstep. So with service name, you really need to name your services. So let's call this hello server. And then if you're connecting to Lightstep, you need an access token. So let me show you about that. So if I go into lightstep.com, so this is my account. You can see some old runs of all this stuff hanging out here. But if you have a Lightstep account, to get your access token, you're going to go down under settings, and you're going to find access tokens here, and you're going to copy that access token and paste it in there. So that will get OpenTelemetry installed, but it's not going to do anything because we haven't added any instrumentation. Now, in some languages that allow some amount of dynamic programming, we do try to auto-install all of this instrumentation by detecting what dependencies you have in your dependency graph, matching those with instrumentation libraries that we have, and then installing those instrumentation libraries. For better or worse, Golang does not take that dynamic approach. Anyone who programs in Go for a while knows that the language is really against magic and against kind of spooky things happening in the background. So there aren't really any facilities for doing that kind of automation in Go, because it's just not the Go way. The Go way is that you should take the extra time to write it down, and then it's all written down in obvious so other people can follow it. Okay, that's fine. That does put an extra burden on people trying to do distributed tracing in Go, though, because you do really need to make sure that you install the proper set of libraries and plugins. And by the way, quick pitch for my docs, if you go to OpenTelemetry.lightstep.com, I have a walkthrough here that you can use. And that will cover a lot of this stuff as well. So I highly recommend after this workshop using this this as your kind of go-to for getting started. I say that because I wrote it. But in terms of library and framework support, you can find them here in OpenTelemetry Go contrib. This is where all of our current instrumentation lives. And so you can see it right here. So there is a pile of popular stuff, but it's not everything. So the first step is to really make sure that the stuff that you want is actually represented here. And if it's not yet, then getting it written is probably the next step. So you could contact the OpenTelemetry crew and maybe even make a contribution on that front. Adding instrumentation is definitely a place where we're looking for help. And it's an easy place to plug in. But in this case, we're just using our vanilla net HTTP stuff. So you can have a look at this. Let me see. I think I had a link. What am I doing? I did want to link to those docs. So hotel HTTP here. Here we go. So if you want to get started with HTTP and OpenTelemetry, the hotel HTTP package is how you kind of connect this up and wrap up all of your HTTP stuff. So in this case, we can have a look at this handler func. Rather than adding it straight in, we're just going to say hotel HTTP and say new handler. There we go. Pop that in there. I'm gonna call this TED server just so we can find it in the background. But that's basically it, right? So we've now installed OpenTelemetry and we've added our HTTP instrumentation. So let's just see what this looks like. So now if I start this server up, I go to localhost. Hello world. I'm just gonna hit refresh here a whole bunch of times to see how this works. And then I'm gonna go into Lightstep and see if these show up. And here we go, TED server. So if we go and have a look, then you can see we've got the world's simplest trace, right? It's a single span just covering this HTTP endpoint. But if you look inside of that thing, you can see we've already got a huge, rich amount of attributes and data that this instrumentation has added to this span. So all of these conventions, semantic conventions around HTTP and networking are all here. You can see which instrumentation package actually created this instrumentation. There's just a lot of good stuff here. And so that's the level of instrumentation you would get out of the box for an HTTP endpoint, which is really, really quite good. But let's have a look and see if we can go about adding, decorating this with some more information. So if you want to decorate this with some more information, this is where we're actually going to need to create a tracer. So the way you do this to actually trace is, oops. Oh God, what are you doing? Okay. So when you create a tracer in Go, you want to create it at the package level. And when you do that, you want to name it after the package. So in this case, we're going to name it main. Like that. And the reason you name it, this is where this information about instrumentation name comes from. So every tracer is named. By the way, you're not creating a new tracer instance when you do this. You're literally just naming it. And that name should match the package that, that generated that data. And by doing that, that means anything done by this particular tracer will get attributed to main. So you can just see, if you're trying to hunt down where this instrumentation came from, this is your hint. So let's actually try giving that some work here. So one thing you're going to need, of course, is a context object. So rec.context is where we're going to pull this off of. And then to get your currently active span, you can just say span context. You could if I knew how to type. So I know how to type. There we go. So again, you're seeing the importance of context here to OpenTelemetry. So everything is context-based. You'll see that like almost all the functions take context as an argument. But the span is the currently active span. This represents the operation that we're currently in. And so this is the span that was created by this handler wrapper right here. So the span we're going to have available is that span that you've already seen here in the background. So that's this span right here. So once you have that span, then you can, of course, do whatever you want with it. So let's say attributes, right? And then we're just gonna label them. So you can say this string. The key is going to be object ID, and then the value 123. So that's adding an attribute to this thing. Let's give that a shot. Go over here to my local host. Refresh this a whole bunch. Go have a look in here. Grab one of the latest, and you can see project ID showing up right here. So it really works. So this is a good place. Like this right here really is enough setup to actually play around with the API and learn a lot about it. Another important thing is recording errors. So span like record error is important. And it takes context. So if we do that, record an error, let's start this back up. Refresh this a whole bunch. And you can see that an error has been logged onto this. But you'll notice that it hasn't marked this span as an error. In order to do that, you actually have to change the status code. So just recording an error doesn't automatically means the entire span or the operation has failed or in an error state. There's like many other reasons why an error might happen. But if you are like, oh my God, this means that there's a problem, then you can set the status. Let me see, what's the API for this? So it's just the code and the message, so that's easy enough. So OpenTelemetry has status codes. The only code you really care about is error. And then you can set a message. So by setting the status to error, running the server again, it's gonna be a lot of fun watching me go through all these steps. Refresh on that a whole bunch. Have a look at it in Lightstep. And you should see this actually be marked as an error. I'm not sure why it's not doing that. That's actually a thing I was noticing yesterday. There does seem to be something slightly funky right now with recording errors, but we expect that to be resolved in like a day or two. And just so people know why that's happening, it's actually because we just changed how the status codes worked in OpenTelemetry. OpenTelemetry used to have a lot of status codes, and people didn't really like them because they weren't sure how to actually apply them. They were sort of adopted whole hog from a set of status codes internal to Google. And we sort of did an about face on that at the last minute and decided rather than having lots of status codes, let's just have 2 status codes, error and OK. So by default, the span status is unset. You don't need to set the status at all unless you think it's an error, in which case you set the status to error. And the only time you would set the status to OK is probably inside of a collector or somewhere else where you're trying to explicitly suppress some kind of error reporting. So OK is a way to send a message to your analysis tool that even if this would count as an error, or even if you were going to raise an alert on this thing or do something, please don't. I am signing off that this is OK. So it's a way to do error suppression. But I think as a side effect of that, we're not currently picking up on those errors. So my apologies. But normally that would work. So you record error and then you set the status for that. So that's how that stuff works. So we looked at setting attributes. We've looked at recording errors. Let's just look at events. You can just do span add event. And it's the same deal, context, event. And let's have a look at that just to prove that that works. Go here. Refresh. Go have a look in the Explorer. See some new things come in. And you can now see the event is showing up here as well. I would love to improve Lightstep's display for events, by the way. If you have opinions on that, please let us know. So that's it. Those are the basics. Everything you're going to do on a span pretty much can be summed up right here. So you're setting attributes. These are indices for the entire operation to be looked up by. You're recording errors and setting statuses as needed. And then you're doing add event basically as a replacement for logging. And you'll notice some of these things that they're pretty verbose. It can be kind of verbose sometimes to write some of this stuff. So I do recommend wrapping up a lot of this in some kind of convenience layer that you use internally. I find that that can save a lot of typing. We'll probably add some more convenience code to OpenTelemetry in the future. We just didn't want, we wanted to get the stuff we knew worked at the door before we got all crazy with adding sugar to everything. Ways to actually make this API be like a little less verbose and have a little better hand feel for application code. For Go programmers on the call who are interested in that, I'm personally interested in it. So feel free to reach out to me directly if you have some ideas on how to like slim down this API as like say a helper layer on top of it. But those are the basic span operations. We're going to get into child spans and things like that in a second. So actually, let's just go straight to there. So we've set all of these attributes and events on an existing span, but what if we want to create a child span and put all of these on that instead? So to do that, you would just grab the tracer and you would say start, and then you would take the current context and you would add on top of that, oh gosh, I'm trying to remember. I think it's just the operation name. Yeah. So another operation. Let's say we want to have a subspan. And then this is going to give us back a new context and a new span. And then you always want to close the span. This is number one gotcha in OpenTelemetry is hanging spans, forgetting to close the span. This is like one of the few places where we have state that you have to track in OpenTelemetry. So that's a gotcha. But luckily, you know, if you're using functional closures and the like, you defer as your friend here. So by adding this new span, what we're instead going to see is now, when we restart this, we're going to see that we're going to have all of those attributes and events we made put on a tiny child span. Oops, didn't wait long enough. Here we go. Oh, and we're getting our errors finally. Sweet. Yeah, okay, so here you can see we have our initial hello span, and then we now have this child span that we added, and on this child span, we have all of these things that we added. So you can see that the instrumentation comes from main, as opposed to this instrumentation, which comes from the plugin. You can see the attributes that we added, and you can see the events we added. So that's how you create a child span. Quite simple. That's really all there is to it. Hopefully I explained enough of the OpenTelemetry basics. I just realized I didn't really explain what a span was, and I'm hoping people showed up maybe with an understanding of that. So I'm going to move on next to writing the client version of this so we can see the distributed part of it working, but this would probably be a good time to stop and just have a look at what kind of questions people are asking. So I'm going to go through these questions now. If people have other questions, now would be a good time to ask them. So Ryan asks, what are some of the biggest consumers of OTel in terms of collecting spans for apps that process millions of events over minutes? And how do they configure the OTel client to handle that kind of load? I see. So the biggest consumers of OTel, I mean, I assume this is maybe like what analysis tools have the highest throughput rate in terms of consuming information. I know I can't speak for other systems. I work at Lightstep, so I can speak for Lightstep. I mean, we're processing like terabytes of data. So we find that there really isn't a problem when it comes to processing those events from a Lightstep standpoint. As far as getting those events to Lightstep, that's where the collector comes in. OpenTelemetry is efficient enough that the overhead of generating those spans isn't super crazy. And as far as the work of processing and transmitting them, the bigger your system is, the more of a kind of tiered collector architecture you're probably going to need. So I recommend the first tier is like a sidecar, a collector running as a sidecar. And that's just to get the spans off of the process, out of your application process and into another process. So if anything weird or bad happens to your process, it won't be affected. It also prevents, memory and overhead from growing because your process is having to hold on to all these spans. So I recommend at minimum shoveling all your data out of your process into a collector. And then you may have to have a tiered set of collectors operating as gateways as a way to provide some amount of buffering between the system consuming the data and the system producing the data. You may need some amount of buffering in the middle just to deal with the operational mechanics of all of that. And so that's where the collectors really shine, is they can provide that buffering that you might need to do in the middle to do things like deploys and handle outages and network rollovers and stuff like that. So hopefully that answers your question, Ryan. Next question is, so basically we will have to either use the OTel libraries, which are pre-instrumented, or do manual instrumentation. Yes, this is the sadness of Go. I am so sorry. In other languages, it is possible to automate this stuff a lot more and also use things like annotations and whatnot. In some languages like Java, a lot of it can be truly dynamic. But on a fundamental level, Go just doesn't work that way. Go is a very explicit manual-oriented language that believes that readability is paramount. And if you do a whole bunch of this magic in the background, then it becomes harder to read. The payoff, or the price of that readability is, of course, the time it spends writing all this stuff. So I do feel you. This is the one language, I would say, of all the languages out there, Go is definitely the most manual implementation heavy version of OpenTelemetry. So apologies. Can logging be done in JSON format? Yes, there is a JSON version of OTLP in the works. And you can create an exporter really for any format that you want. So there's no reason you can't export in JSON. And then someone else, Mr. Ben here, says, is it possible to send or export Prometheus metrics to Lightstep? It is definitely possible to start sending some basic machine metrics to Lightstep. Actually, these the Go launcher will do that out of the box. You'll notice it was sending me this warning that metrics are disabled by configuration, no endpoint set. So if you actually go in here and add a metrics endpoint to this bad boy, which this thing right here, this will start processing like basic machine metrics like CPU and RAM and stuff like that. But we don't have a fully fledged metrics product at this time. So we don't really process Prometheus metrics in that respect. Cool beans. All right. Well, those are some good questions. Let's switch back to instrumenting the client. So let's add a client to this thing. So we're gonna go here, new, Go. And let's see. So same deal, we're gonna say package main, and we're gonna probably just do something super basic. We're just gonna make a request, that endpoint, so request, and then here, so like say client, and then just make a request, be like client or request, how do you say that? And we're gonna say get close 9,000 slash almost. And then we're gonna say we're automating OpenTelemetry installation. Can we automate error handling while we're at it? That's the request. We're going to just say client dot do my request. Am I typing this again? Okay. enough arguments, it says, but there's so much Zoom Chrome, I can't read what it's trying to tell me. Oh yeah, add that nil. There we go. Okay, so this is going to make a request to that same endpoint. So if you go back here and we run our server, here we go to walkthrough, and we say, we run our client, run our client, client. That should allow us to see basically the exact same thing we've been seeing. And sure enough, here we go. So we're still seeing just the server spans. The client hasn't been instrumented yet, but we do see the client works. Okay, so let's add the configuration. So no need to retype this stuff. Just bring it over. We've now got the OpenTelemetry launcher installed. And then again, the same deal, we have to add some instrumentation. In this case, OTel HTTP gives us transport, which is the way to actually hook in where we need to be in order to be doing a lot of the injection and extraction stuff we need to be doing. And that's that. That should be the only thing we need to add. So let's give that a shot. So we're not even going to restart our server. Run the client a bunch. Go over here. And here we go. So now when we're seeing spans, we're seeing a connection of spans across services, right? So we have our client span here, and then we have our server span here. And you can see because our server does literally nothing but print hello world, most of the overhead here is in the client, right? So this is where you see the setup of the network connection and all that other stuff, because there's basically nothing happening in this server. We could change that though, if we just go back to this server and let's say we want to add like time.sleep. Okay, I just added some sleeps to that server. And now if we try to talk to it, now we can see because of those sleeps, you can see a little more where the time is going, right? So we said another operation was going to sleep for 30 milliseconds. We see you're clocking in at 31.7 milliseconds right here. So that's maybe a little more reasonable looking trace. Okay, so that's that, right? That's really all you have to do, and that's because all of this instrumentation is doing the context propagation for you under the hood. To give an example of using this with baggage, I think this is another good way to have a look at this, is let's try just propagating a baggage value down the pipe. So let's say that we want to, let's say that this project ID attribute here is not something that we have access to in this server for some reason. Let's say that the client knows the project ID and we don't want to be making some kind of database call to figure it out here. So what we can do here on the client is just add that. So let's see, so we're just like context, I'm gonna say like hotel.context with baggage values. And then we don't have a context right now, so we're gonna say context.background. And then string D456. Okay. So we now have a context that has our baggage values in it. And then we need to make sure that gets into our HTTP requests. So we have to switch to using the context versions of these things, so we can pass the context in there. And that should cause us to start sending this project context. So let's go back over here. And we're gonna instead say, let me look at my notes real quick. Yeah, okay. So if we're gonna go here, we're gonna get that project ID. By looking at this hotel baggage. So here in the client, I'm putting this baggage into the context, and then here in the server, I'm pulling that baggage out of the context. And then if I want to actually use it here, then let's see. Then we're going to want to say, just do it this way. Like that. Oh, because that's value. So we got to say label key value. There we go. Okay. And I've changed the value to 456 here, so we can actually tell that this is working. So we go to our server. Now we run our server. And we start running our client. We can go back in here to Lightstep. Have a look here. It should work, but it didn't. Why did I not see it here? That's interesting. So how do we debug things? This is a great example of like, how do I debug things? Something's not working. I'm curious about whether this context is actually being propagated. So let's have a look at how we could figure this out. So if we go into our client, I would love to know that these baggage values are actually getting added to this request. So we could be like funct.printf So first step is I want to know, is this actually getting added to the headers? Now if I run the client, nothing in there. Well, maybe that's the wrong place to look. Let's look on the server side. So on the server, here we have a request. So great. Let's have a look at this. So I'm having a look at my headers. I can see that I'm using the B3 headers for span and trace. And I can see that this baggage header is not actually there. So let's see. Let's see what I did wrong. We're going back here into the client. We've got our context. We're adding it to our request with context. And that really should be it. That's interesting. Huh. Well, that's a mystery I'm not going to try to unravel right now, because that should actually be working. So interesting there. I would have expected this to actually work, and it was working yesterday. So what are you going to do? Okay, well, you could see how that would work. Apologies for not actually going through with it. I'm not going to make you sit here while I muck with it too much. Maybe later we can get back to mucking with it. But that's the basics as far as a walkthrough goes for getting started with spans. So do we have any questions at this time around this span API? Are there any examples of this I can get into and show people? Yeah, and Ariel, I'm not sure if grabbing the bags out of there would really make a difference. I grabbed those earlier just to have a look at them. So a little funky, a little funky. Okay, so moving on, one thing I do want to mention, we haven't really talked about resources. So we've been talking about spans and attributes and errors, but you also want to use resources to describe how your service actually runs. So you could think of resources as basically attributes, but for your service. And so you can add those here. So I'm sure resource attributes. This just takes a map of string to string. And then anything you put in here is going to go onto your app. So my resource key, my resource value, and here we go. Oh, and we're getting called to do break time. Well, yeah, we are over break. My bad. We should do this. So let me just, yeah, why don't we go on break? And then when we come back, if I've solved the baggage problem, I'll update people with that. And answer more questions at that time. So we're going to take a 30, actually, let's just take a 15-minute break. and come back at 11. Does that work for people? So we'll see everyone back here at 11. How's that sound? Bio break time. Hello, hello. And it's 11 a.m. and we are back. Hopefully you all are back too. So we can go through your all questions, but first I figured out what I did wrong, and it's really silly. My issue with baggage was I had not installed the propagators. So the OTel launcher only installs the B3 propagator by default, and has a funky way of letting you add extra propagators. So you have to add a CC. This is really silly, but basically baggage used to be called correlation context and then got its name changed back to baggage. So this really should be changed to baggage, but right now it's called correlation context. So that's a weird little gotcha. I actually have an action item now. I really think these launchers should come with the baggage propagator installed automatically, because that's kind of unexpected to have no propagator. But this is how you configure them. So with the launcher, you can configure this stuff using with propagators. And if you add this line here, that will cause the instrumentation to actually do the propagation. So if I run that now, oh, am I not sharing my screen? I'm an idiot. Okay, try this again. Okay, from the top. So this was my mistake, is you need to add, just when you're configuring the launcher, to add with propagators and to include the correlation context propagator. I'm sorry, this is a little silly. This is where the we're in beta kind of comes out a little bit. I would like to actually see the baggage propagator come by default with the launcher, because I think that's more appropriate. So we're going to get that fixed. But if you add this propagator to the server and to the client, the propagators are matching, then everything else shall work. So you start the server. And run the clients a couple of times. And go over here to open to Lightstep and have a look. All the latest stuff coming in. And here we can see that our project ID is set to 456, which is the value that we set project ID to in the client. So this is a piece of baggage that was started here. So it was a value we wanted to do some indexing with that was available in one server. And so we added it to baggage and then used it to create an index later on a later span. So that's the primary use case for baggage right there. You can do other things with baggage, like application level, interesting things like feature flags and stuff like that potentially. But really right now at this time, we recommend only using baggage for observability and not making your system potentially depend upon it. And the reason there is it's easy for something like context propagation to be broken at this time, because HTTP services don't do context propagation by default. So I don't think you should depend on something like baggage for application for application critical features right now. You should only do it for observability. That's my current take on baggage. I do think it can be expanded into other really interesting domains like A/B testing and security and authentication and stuff. But that's like next version. That's not where we're at yet. But I did want to show you all that baggage does in fact work. Okay, so that was the actual end of that walkthrough. Y'all had some good questions in the Q&A, so I'm going to go over that right now. And then we'll move on to more like best practices. How do I set this up? How do I roll it out? So first question was, record error generates a log event, not a set of attributes. That's correct. Errors are events in the sense that they have a timestamp associated with them. Events can also have attributes. The real difference between an event and an attribute is that events have timestamps and multiple attributes, you might think of it. So that's why an error is an event. The span level attribute is the span status. It's not actually an attribute, it's a field on the span. But setting that status to error, that's the sort of span level aspect of recording an error. But if you're just recording an error in terms of like, I'm just trying to record an event that occurred, then record error is basically a convenience function to record an error event. So hopefully that explains that bit. Does OTel define a follows relationship between spans as in open tracing? So this is actually an interesting question. So to provide some backstory here, the kind of parent-child relationship we've been showing here is entirely synchronous. We're only looking at these synchronous transactions so far. We're not looking at anything asynchronous. For example, let's say you do a transaction like this, and as part of this, some kind of background processing gets kicked off. You want to show that there's a link between the background processing going on and the original transaction. And in open tracing, the way we did that was as a single trace that was used a different kind of parent-child relationship called follows from. So that was just an indicator in the graph when a relationship between spans was asynchronous. So in OpenTelemetry, this works a little bit differently. And actually, this is an area where I would like to do a lot of work going forwards because it relates to observing message queues and a lot of other workload patterns that are not these transactions. But what OpenTelemetry has is it has a concept called links. So it doesn't have a follows from relationship. It just has regular parent-child relationships in a trace. And if you want to link multiple traces together, you can do that using the links feature of the OpenTelemetry span. So the idea there is for these asynchronous workflows, they're actually separate traces. So your background job would just be its own trace, but then you're saying these traces are related to each other. So that's the way OpenTelemetry is sort of heading towards that. And that comes out of more the open census model. The open census model worked a little bit more like that. And there are aspects of how they're using links to handle scatter gather patterns and things like that that looked attractive to us. So that's why we ended up going with that model. So hopefully that answers your questions. You use links to do follows from. Okay, so Ben asks, how can a span be manually propagated? Specifically when using a model other than HTTP server client, when using a message queue or other form of pub sub mechanism. That's a great question. So what you need to do in that case is one of two things. You need to, let's just say one thing. What I think you need to do is create a propagator for that particular service type. So you're not going to be able to use the HTTP propagators, but you can write your own propagator to inject and extract from some other kind of carrier. So that model might work if you're saying it's still the same model of I've got this context and I want to inject it into this metadata, only this metadata is like Kafka metadata on a Kafka message. So writing your own propagator is the way to handle that. And you can look at existing propagators to get a sense of how to do that. So basically the way that stuff works, just to point you at it potentially in the docs. So if you go to look at, let me find them. So here's a propagators package with some examples of what you can find here. So basically, you just need to implement extract, inject fields. This is the basic structure here. And you can look at these existing implementations for how to do that. And then it's really just calling inject and extract using calling inject and extract on the carrier that you want to use. So carrier is our term for the thing you're injecting or extracting from. So you'll have to take whatever that object is that you're injecting things into, let's say that's Kafka metadata, and put that behind a text map carrier interface, assuming that it's ASCII text. If it's binary, then you need to use the binary propagator, which I think are still, that's all still in flight. So we don't have text map propagators at the time. So hopefully that answers. So you need to add, you basically need to make your own propagator. And if you're looking at doing this for some kind of something that's common, again, like Kafka or AMQP or anything like that, I'm really interested in modeling that properly. And we definitely want to get that into OpenTelemetry. So that's a great thing to come get involved in the community with, if that's something you're interested in. You're going to discover that there's more difficulty in tracing message queues and these kind of pub sub formats than just inject and extract. For example, you're often caring about not necessarily how much time was spent in each operation relevant to that particular message, but you care a lot about the gaps, like what happened between these times when it was, being run through one of these systems or something like that. And you also have a lot of these systems have batch modes that they work in that require some thinking about, because you can't do this easy closure approach where it's a transaction. If you're instead trying to process 50 messages, because you have a batch of 50, you have to think about like how you actually, like, is each message becoming its own trace? Is the trace processing those 50 messages? So unlike HTTP and those more, ordinary RPC things people are used to, message queues come up with like a number of different topology issues that I think need some specific thought. You can't just inject and extract and have it be totally helpful, though that is a great way to, get those IDs moving around. So it's a bit of a long answer, but hopefully that answered it. Feel free to follow up because that's an important question. Okay, Renato asks, would sampling be disabled for traces that have errors on any span? If not, is there a way to disable sampling in such cases? Yeah, so sampling. So sampling, again, is really dependent upon your backend system and how it works. There are some systems like Zipkin, for example, where all they're doing is upfront sampling. So they're basically flipping a coin and deciding whether sampling is going to happen or not upfront. Other systems have what is called tail-based sampling. So Lightstep is one of these systems. So the way we work is we actually don't do any upfront sampling. We collect all of the data into our satellite layer, which we referenced earlier. And based on what we see there, we choose to sample or not sample things. And that allows us to do things like heavily sample errors or identify outliers. So we really want to heavily weight the exemplars that we capture to be rare, weird things, like, not just errors, but also like what's a request that's in like the P99 of latency. We want to prefer trying to capture these strange, unusual events. And the best way to do that is to capture all the data first and then only choose to store some of it. But unfortunately, you can't really mix and match. There isn't a way to do this without storing the data somewhere. So we might be able to bake in a bit of this into the collectors at some point, but probably not soon. Again, because the collectors only know about the data that's been sent to them They don't have a way to like look at all the spans from other processes that may have participated in the transaction that sent their data to another collector. So really that's, I would say, is an analysis tool feature right now is having that kind of nuanced sampling. So hopefully that answered that. Ariel asks, when should we prefer baggage over request parameters? That is a good question. So I would say the main purpose of, you should prefer request parameters. Let me put it that way. You should prefer writing normal code the way normal people write code and not get grabby with this observability code or the kind of cool sort of unobtrusive way things get passed around. It's sort of the same rules you might see for the Go context, the way the Go core community references like when should you put stuff in context versus a function parameter. It's basically the same. It's the same idea. If it's the point of baggage is that you may need these values way down in your system, but the idea of adding in all the code to sort of bucket brigade, shovel this value from like one request parameter to the other so you can get it to a service, 3 layers deep, that's a huge amount of work. And the purpose of baggage is to be able to flow these indices and correlations through your system without having to do that work. So basically you should use it just for flowing correlations at this point. I don't recommend using it for other things. And obviously, if you don't need to put it in baggage, if it's easy enough to get it as a request parameter, if it makes sense as a request parameter, you should put it there. So hopefully that helps. Okay, the next question is there a common pattern that you recommend to instrument to a code base more than 1 million lines of code? Oh yeah. The whole next bit of talking is about that. So we're going to get to that question in just a second. And then, are you aware of any studies on the overhead OpenTelemetry introduced to service, both in terms of CPU memory footprint? So we do not currently have performance benchmarks for OpenTelemetry outside of the collector. The collector has performance benchmarks. As part of going GA, though, we do want to have those kinds of performance benchmarks being run on every release so we can catch regressions and stuff like that. So I don't have an answer for you at this point, but the idea with OpenTelemetry is that out of the box, the stuff it's running should be low overhead enough that you can run it in production. So the idea is that OpenTelemetry's instrumentation out of the box is trying to thread the needle of giving you enough information that it's useful without getting to the point where it's noisy and you wish it wasn't there. Cool. And then Ben says, I see, thanks. No problem. Okay. Okie dokie. Let's get into phase 2 here. So how do you roll this stuff out? So one question we have here is like where you have to ask when you're trying to roll this out, and this especially goes for someone with like a giant code base, right? So you have a bajillion lines of code, and not only do you have a bajillion lines of code, maybe you have like a lot of teams, right? It's not all your code, there's other services, it's a distributed system. And so there's a combination of like, you have to do all that typing to get this stuff in everywhere. And then you also have to get buy-in from other people in your engineering organization, because you can't really take an ad hoc approach to tracing very well. And it is true that the bulk of the coding work is going to be in the instrumentation. If you look at all of the code in OpenTelemetry, the SDKs, the clients, the backends, like setting up and installing that stuff, it really isn't a lot of code. All of the code is instrumentation, whether that's the instrumentation libraries that we're trying to get added or instrumentation code within your application. That's really where the bulk of the work is going to be. So it is true if you have a very large code base, you do want to be thoughtful about how you approach this and try to avoid boiling the ocean. And so a good way to do that and to get buy-in is to find a real problem. Rather than trying to boil the ocean and just get everything instrumented everywhere, because that might fail. Identify some kind of transaction that you care a lot about. It could be something that already has some known latency or performance issue or something wrong with it, and you'd like to get to the bottom of that, but you've been having trouble. That's the ideal thing. If you don't have that, then just starting with something that's high value. Picking some particular transaction path that's high value, and just try to get that instrumented. And when you do it, we tend to say breadth first, not depth first. And what we mean is try to get basic instrumentation added to each service. You don't need to have really detailed instrumentation to get started with. You just need to have the minimal amount you need to cover your framework, your network requests, and to get context propagation working. And so it's a much better approach just to try to get those basics in there and get a complete trace on something you care about being reported to the system you're using to observe it. If you have that kind of focus, then that will allow you to kind of get to the point where you're seeing value before you're doing all of the work, instead of trying to do all of the work and then turn around and see what was valuable about it. So I would say if you have a large code base, this is the #1 thing to look at. You know, I might also mention, oh shit, what was I supposed to say? If you have a large code base, then you're gonna want to take this approach. And you're also, I just really feel like I have to emphasize that it's not like you have to put in a bajillion logs for this stuff to be useful. Like the standard attributes that you get are going to be useful. The basic coarse grain latency and error reporting you get is going to be useful. All of that is going to feel better than the way you were poking through logs and things before. So I really think you want to get there. The other thing I think that's really important for large systems is to try to somehow centralize observability in some way. And usually in order to do that, you have to have other aspects of your distributed system and your deployment operations and all of that centralized in some way. So hopefully you have a giant code base, but with lots of services, but hopefully those services are all using a lot of common frameworks and components. It's that centralization point that you want to go in first. See if you can get all those shared components instrumented. Okay. And then of course, once you've got that first trace going, you can then expand from there, right? Start looking at other services. There's a thing we jokingly called blame-driven development. And I'm really joking here, but one thing you do find is people are trying to figure out where latency or an error is coming from. And so they start tracing their services and they eliminate it coming from any of the services that they've traced and can clearly see it. The issue has to be in some service downstream from the services that they're looking at. So you can use that tracing data to go to that service that's downstream from you and say, hey, look at this. We're seeing, you know, these latency numbers and stuff. We're pretty sure it's coming from over here. Can you add tracing to your service so that we can find out where in your service it is, or if it's actually a service you're calling? So that approach is a nice way to tie some value to the goal of adding tracing. And how does it go wrong? So many ways. But I will say the thing we see #1 is because you can't really get started in a corner with tracing, you have to do it to some degree. You have to have some continuous amount of stuff instrumented for it to be useful. A way we see this go sad is that people, perhaps one of you on this workshop, are really interested in tracing. You want to champion this stuff. But you don't necessarily have a lot of leverage to make that happen. And it starts happening in an ad hoc manner because you're going around and asking different teams. Could you please add this? And some might do it. It comes out inconsistent, and it never reaches a critical mass. And so that's really the thing to avoid. It's avoid kind of ad hoc adding tracing here and there without some kind of plan, unless you have a very tiny system. Because you really want to make sure that when people are first trying out tracing and getting to know these tools, they're working with good data. Like the tools are actually set up the way they're supposed to be and reporting the kind of data you'd want to see. And that's easier to do if you, as the person who's championing the tracing effort, can kind of make sure that those initial traces that get instrumented are decent. So that I would say is the number one way things go wrong, is it's just a kind of unfocused effort. And yeah, well, that's basically what I'm saying on this slide here, right? Like, if you don't have like a project plan or project management, that can make things go wrong, because again, you're dealing with multiple teams, a larger organization. It's not necessarily a little library you can just start using in a corner. And as much as possible, I recommend having some centralized resources in your organization about how to do this. So like, documentation, but also helpers. I find you can take a lot of this OpenTelemetry stuff, and it's meant to be applied to a lot of different situations, but you may have just some very straightforward situations that you're doing over and over again. And so helper libraries, or anything that makes it easier for other developers who are not observability nuts to just start copy pasting code, really helps a lot. So those are the pitfalls and best practices of getting started with this stuff. So I'm going to leave you with a little rollout cheat sheet here. So we're coming up to the end. Again, just to go over the tops of this, I do think that there are 4 languages that are getting to the point where you can use them in production: Go, Python, Java, and JavaScript. That's both browser and Node.js versions of JavaScript. If you're trying to get buy-in from your org, really starting from a known pain point or some kind of win that you could get from tracing is more helpful than trying to boil the ocean. You can find a lot of docs both on OpenTelemetry.io and also otel.lightstep.com. This is where I'm only just getting started here, but I plan on adding a lot of resources to this. So if you're interested in the resources that are there and you want to see more, please let me know. I'll try to keep posting updates about this content that I'm creating on Twitter, so you can follow me there if you want to keep track of it. And last but not least, I didn't do a shout out about this before, but I should do it here. We're starting a Discord at Lightstep to answer a lot of these kinds of questions. So if you get done with this workshop and you have more questions, or you're looking to actually get started with this stuff and you're running into some trouble, besides the OpenTelemetry Gitter rooms, you can come talk directly to us. So I'll be in there, Austin Parker will be in there, other Lightsteppers. So check out that Discord. I'm gonna add this to our chat real quick. So that's another great resource if you're just trying to get maybe some quick answers to some of these questions as you get rolling. And that's what I got. Thank you all for coming. I'm gonna turn back to questions at this point, but that's the end of the official lecture. So let me see if I can answer the questions already in here, but if you have more questions, please put them in. Otherwise, it's been super great. Thank you so much for attending. Okay, so Kevin asks, how does OpenTelemetry account for clock skew among different servers? It doesn't. That is the answer. There's no good way to account for that in the sense of trying to manipulate the data or somehow get a handle on what the cause of the clock skew is and correcting it. I've actually seen some attempts at clock correction in distributed systems, and it just doesn't work well, because it's, at the end of the day, it's a heuristic, like the clock problem is a real fundamental problem. And there isn't a way for OpenTelemetry to get around it with some tricky clock correction. Now, that said, what OpenTelemetry does is it just shows you the timestamp numbers. So if you do end up with clock skew between two different processes, you can really see that in the trace. It leaps out at you because you'll see that you'll have these spans that are obviously connected to each other, and they're like ridiculously separated in time, or they're inverted, so the happens before looks like it's happening after. And so by just honestly showing you that data, I think that's the best thing OpenTelemetry and tracing systems in general can do for something like clock skew. Not try to correct for it, but just honestly show you the times so that you can figure it out for yourself that there's something going on. But the clock skew won't affect things like parent-child relationships or the actual graph you're forming, because that's not based on timestamps. That's based on IDs. So the clock skew issue isn't super critical in that respect. Okay. And this is going great. Oh, thank you so much. Please do share the recording. Yes, we're totally going to share this. And I plan on turning this into some YouTube videos, like content like this, into some shorter YouTube videos and written content as well. So I definitely want to get this content out there. And thank you so much for enjoying it. And then the last question we have at this time is, are launchers Lightstep specific? So they are not. The features that they offer right now, the configuration options, are tilted towards the stuff Lightstep needs. So that's why you have like a Lightstep access token in there, because we have to set that on a gRPC header, and it's like really obnoxious to do that. So the Lightstep options, the ones we care about, are the ones that are baked into the launchers at this time. But the launchers are 100% OpenTelemetry compatible. So just to be clear, this is I've been promoting this idea of OpenTelemetry distros, and this is our version of what we think a distro should look like. And one super important rule I have about distros is they can't fork OpenTelemetry in some way or block you off from using the other features. So something you can do is you can use the launchers, and if you need to grab at configuration stuff that they don't give you, you can just use the vanilla OpenTelemetry version of those configuration options. Like they will all still work, and they don't compete with the launcher. So basically run the launcher first and then do any additional bespoke OpenTelemetry configuration you want after you've used the launchers. So that's my recommendation. And I am imagining other systems that do have some tricky things you might have to set up, or access tokens or stuff like that, or plugins or sampling. I am hoping that those systems will come out with some kind of OpenTelemetry distro, so you don't have end users installing the exporter plugin but forgetting to install the sampling plugin and some crazy stuff happening. So that's where I hope it goes.